of lighting system. Let me introduce myself. I am V.Jenitha, Assistant Professor of EEE Department. So today's class we are going to see about lighting system. So these are the overview. So these are the overview of today's lecture. So today we are going to see about types of lamps. So types of lamps we are going to discuss about construction working of incandescent lamp, sodium vapor lamp, fluorescent lamp. Then we are going to discuss about the comparison between the incandescent and the fluorescent lamp. Then we are going to see the emergency lighting system on ship. Then what are the type of signal light used on ship. So what is the purpose of navigation light and what is the function in the operating in the ship system. Then how we are going to select the cable for the shipboard lightings. So these are the topics we are going to discuss in this session. So first topic we can discuss about the incandescent lamp. So in general we are going to what is the lamp working. The lamp working is about we are supplying the given the energy. So what it converts the electrical energy to the light energy and the heat energy. So nowadays we are preferring CFL lamp, that is CFL lamp, LED lamp are most commonly used because in today's scenario incandescent lamp are not commonly used because it produces more amount of heat compared to all other lamps. So in the incandescence what happens, 60% of energy is converted to as light energy and remaining 40% is converted as heat energy. So there is many loss. So the efficiency is less. So compared to this we are preferring another option, LED, CFL lamp, someone. So first you can see the working and construction of the incandescent lamp. So here this incandescent lamp is also called the filament lamp because here we are using the tungsten filament as a material. So what happens, we are producing the when the supply is given, the filament get heated and so it converts the energy to the visible light. So we are going to discuss the construction and working. So this is a incandescent lamp. This is seen in everywhere. You can see in home. So here this is an incandescent lamp. So we are having the construction as here outer layer is covered with a glass cover and inside we are having the filament that is made up of tungsten, and here we are having the supporting wires, and here there are two supporting wires and two lead wires. So these two lead wires are connected and it is connected to the exterior for the providing the supply, and here we are having glass stem and heat reflector. So inside this glass we are filled with the inert gases. So what are the inert gases? We are need xenon, argon. So these are all the inert gases. So that will be filled inside this glass cover. So actually filament, why we are opting for filament, we can whether you can use any other metal or any other material means yes, but there is some of the advantage for this filament material. Okay. Instead of filament we can use carbon. Carbon can also be used as the filament, but the tungsten has the more efficient and lifetime compared to that of carbon. So the light energy produced by the tungsten filament is more compared to the carbon filament. So the tungsten filament is most preferred. So the tungsten filament here it is of wound coil type. This is wound because or wound or coiled because by this way the length of the filament can be increased, and so the light energy produced also increased. So when the supply is given. So other than the tungsten and carbon filament, any other metal preferred means because it should be strong and weightless so that it should withstand any vibration or anything. So that's why we are using the tungsten filament. And another point is tungsten has the melting point, high melting point. So we are preferring the tungsten filament. So the inert gas like argon, neon, nitrogen, these are all the inert gas. These are filled inside the lamp so that the tungsten filament it's not melted even though it is heated upon 3200 degrees Celsius. So what happens if there is no inert gas filled inside this lamp? So if there is no inert gas filled in this lamp means then the tungsten gets started melting, so that lifetime also decreases. So that's why it is filled inside the inert gases. So what is the principle of light production? Here heat energy is produced in this filament. So in this range of 0 degree to 3200 degrees Celsius. So initially when the supply is given to through the supporting wires, so the filament gets started heated and the heat energy is produced. So the heat energy produced is in the range of 0 to 3200 degrees Celsius. So once the temperature crosses 3000 degrees Celsius, so this electrical energy is converted to visible light energy. So actually what's the working happening here means, so when the electrical supply is given, so the tungsten filament gets heated. So what happens, there is atoms present in the filament also gets heated. So what happens, when the atoms get heated, the electrons that present in the atoms move from the lower energy level to the higher energy level. Similarly, when the heat is reduced, the electrons move back from the outer level to the lower level. So what happens, there is a movement of electrons. So this change in the position of electrons with the atomic structure, it produces the energy. That energy is released in the form of photons. So this is called the visible light. So this is the principle of light production. So already we have discussed the construction. Yes, there is a outer surface that is called the glass bulb, and inside the glass bulb it is filled with a inert gas. The inert gas may be argon, neon, krypton, xenon, and nitrogen. So these are filled inside this glass. So actually there is insulation provided between the contact wires and the supporting wires, and there is a aluminum cap at the base. So it is provided as the support and it is connected to the external supply. So when the electric supply is given, the entire filament or support assembly is mounted on this aluminum cap. So the working of incandescent lamp, it is the principle of incandescence. That means here the light is emitted by the heating the filament. When the supply is given, the filament gets heated and this heat is converted to the light, visible light, photons. So here what are the advantages and disadvantages? Advantage means it is a low cost and it is easily available and it is very cheap. So it can available in many variant. It can be 15 watts, 40 watts, 60 watts, 100 watts, 200 watts, 300, 500 watts, etc. So it is available in many range. And also it does not affect by the external environment or cold weather. So it is easily available and it is not affected by the cold weather. So the disadvantages of this lamp is the lifetime is less compared to other lamp. So I already told that it is less efficiency, so it is has less lifetime, because here in this type of lamp only 60% of energy is converted as light and remaining 40% is released as a heat energy. So there is a loss, and so that efficiency is less. So as the efficiency is less, definitely the lifetime is also very less. So also it also consumes more power. So that what we are preferring nowadays, we are preferring CFL and LED lamp because of this reason. And another thing, for 40 watts lamps, it is not filled with inert gas. Actually inert gas are filled inside this lamp because it will protect from melting. That is, tungsten is having high melting point, and if there is no inert gases are filled, then the melting, it starts melting and the lifetime will be very short. So this, for below 40 watts there is no inert gas filled. So this is the disadvantage. In applications, we can, for general applications, we can find this in everywhere. That is incubator, car headlight, flashlight. So these are the things we can. It is available, and in ship we can able to find it for navigation light, signal light, and alarm indications. These are the applications of this lamp. Next comes upon sodium vapor lamp. So in this case, this is also called the gas discharge lamp. Similarly, here we are giving the electric supply is given to the lamp. So it converts the electrical energy to the light energy as well as heat energy. So incandescent lamp is called as the filament lamp. Here the sodium vapor lamp is called as the gas discharge lamp. Because here the gas inside the lamp, it gets ionized and produces the light energy when the supply is given. So it is found in street lights, outdoor lighting and playground lighting. So this is the diagram of the sodium vapor lamp. So first we can see the construction. So here we are having the two U-shaped tube. One is inner tube and another is the outer tube. Here in this inner tube it is filled with sodium and neon gas. So here in between the inner and outer tube there is no space, there is no gases or anything filled and it is kept vacuum. So here there is having two electrodes. Inside this we are having two electrodes, E1 and E2 are two electrodes and we are having two glass tube G1 and G2. So inside this inner glass tube it is filled with the neon gas and the sodium gas. Actually sodium gas is act as a main gas and the neon act as a auxiliary gas. So the sodium gas is filled more compared to the neon gas. There is a cathode heating transformer. So it is used to increase the starting voltage. Actually we are supplying the 230 volt AC supply. It is not enough to produce this light. So we need a transformer, cathode heating transformer. So what happens if it is a 230 volt AC supply, it increases the supply. So it increases means we can obtain around 440 volt and it is useful to produce the light. So by voltage gets boosted by 440 volt by using this cathode heating transformer. Due to this cathode heating transformer, the cathode electrodes get heated. What happens here? We are having the electrodes. So these electrodes, when gets heated, it emits electrons and these electrons move from the cathode to the anode. Here also it has the inductor, that is choke. This choke is used to regulate the current flow in the lamp and to maintain the uniform discharge. So here we are having the capacitor. The main function of this capacitor is used to maintain the power factor. So what happens due to this cathode heating transformer, the current gets lag. So current gets lag. So the capacitor is used to correct this. So it is used to improve this power factor. So that is two U-shaped, inner and outer, it is filled, and in between this inner and outer no gas is filled and it is kept as a vacuum. So now we can see the working. So when the single phase 230 volt AC supply is given, what happens? Electrons starts move from the cathode to anode and the neon gas present inside the tube gets discharged. Initially the neon gas, actually we are filled with neon and the sodium gas. Initially neon gas gets discharged. So at initial stage orange color light appears. Then the sodium gets discharged and the ionization takes place. So further we are having the heat. Due to this ionization take place. Ionization, that is the loss or gain of electrons. So that is called as ionization process. And after this sodium gets discharged and yellow light appears. So initially due to the neon gas discharge, orange light appears and then it starts yellow light appears. So this is due to first initial stage, there are having two gases. So initial stage neon gas discharges and then sodium gas gets ionized and appear as a yellow light. Here the heat produced in this sodium vapor lamp is about 300 degrees Celsius, but in the mercury vapor lamp the heat produces around 650 degrees Celsius. So compared to the mercury vapor lamp, the efficiency of this sodium vapor lamp is higher because here the heat produced is less compared to the mercury vapor lamp. By the same time, the lifetime of the sodium vapor lamp is more, that is around 3000 working hours compared to the mercury vapor lamp. So that is around 2000 working hours. The main thing, the sodium vapor lamp should be placed in the horizontal lamp holder. So this is main reason of is the gas present inside the inner tube, it remains uniformly distributed. So if it is placed vertical, what happens, that sodium present inside this inner tube, it settles down. So what happens, that brightness will be non-uniform. So it should be placed horizontal in the lamp holder, so that it remains uniformly distributed and the brightness will be around everywhere. So here the advantage, we can see the advantage and disadvantage. So here this is low cost and the lifetime is more compared to the mercury vapor lamp. Here the heat produced by this lamp is very low. So it has a high efficiency. Here heat produced is very less. So the efficiency is more. Disadvantage, it requires additional heat transformer, cathode heating transformer. So additional transformer is required to boost the voltage to 440 volt. Next, poor color rendering. That is, initially there is no brightness, and after the sodium discharge we are having the yellow light and appear the brightness. So this is poor color rendering, and it is for applied for limited applications, and it requires significant warm up time. So that is, before reaching the full brightness it requires the warm up time period, so it lags the time so to reach the brightness, complete brightness. So this is also the disadvantage of the lamp. Next we are going to see here, next for applications we can preferred in the night time navigations and deck and cargo areas. So these are the applications of the sodium vapor lamp. And next you can see about fluorescent lamp. This fluorescent lamp is called a fluorescent tube, and it is a low pressure mercury vapor lamp, discharge lamp. So it also works on the principle of the fluorescence, and it emits a visible light. Here when the electric current is passed through this tube, actually the tube is filled with the mercury and it is coated by some phosphor coating. So what happens, when due to the reaction, first it excites the mercury vapor and which produces the UV rays. So these rays, what happens, this fall on the phosphor coating inside the lamp and it makes the light to glow. So you can see the complete construction and working. So this is the fluorescent lamp. Here we are having, this is the consist of a fluorescent tube. Here are the main three parameters. One is fluorescent tube, another is electrodes, and here this is covered with the phosphor coating, so that here inside it is filled with the mercury and some inert gas. So what happens, initially this reacts with the mercury and ionization takes place and it produces the UV rays, and when it falls on this phosphor coating, the light glows. So here this is a glass cover and here this is phosphor coating. Here this is a cathode and this is the anode. So the electrons move from this cathode towards the anode, and here the outerwards having the contact pins, which is to place the holder in the holder, and here there are two filaments. So the lamp is made in the form of a long tube. So at both the ends the electrodes are attached. The electrodes are of spiral in shape and it is of tungsten filament, and it starts emitting the electron from this material. So you can see the working of this fluorescent lamp. This is a circuit diagram. So here three main parts are there. First is the filament tube. This is the tube lamp, and here we are connected towards, one filament is connected to the choke and the other thing is connected to the starter. So this is three essential elements are needed for this working. So the choke is connected in series with the tube filament, and it provides the voltage impulse for the starting the fluorescent lamp, and once the lamp is started it acts as the ballast. The lamp filament is connected to the starter switch, which is a small cathode glow lamp with bimetallic. So here it is having the bimetallic strip. So we can discuss about the working. So when the circuit is energized, nearly full voltage is applied across the starter terminals. So the starter switch is filled with argon gas. This argon gas is ionized and glow appears inside the starter switch, and which heats the bimetallic strip carrying a moving contacts. So in a while, the bimetallic strip shorts with the starter terminals. This results in high current. Actually, what happens when the supply is given? Here we are in this choke, we are producing the EMF. So normally, when this initially that the starter, we are having the capacitor and the bimetallic strip, and the bimetallic strip is made in one contact to each other. So what happens when the supply is received here, the starter, it comes towards this end. Actually, the supply is completed by this circuit, and what happens when it starts heated, and at a certain point the bimetallic contacts gets cut out. While heating, it makes the contact to cut out, and sudden imbalance occurs in this choke. So there is a high impulse of voltage and high collision occurs here. So it creates a plasma path between the electrode moving parts. So what happens? The electrons are moved towards the anode. So that from the cathode you are moving this anode, and here it creates one plasma path. So once after this starter creates this imbalance, what happens? The starter is not necessary, because here the plasma path is created. So the electrons move here and there. So what happens? There is a movement, plasma path. So there is a high potential created. So this what happens? This ionizes the mercury. Actually, inside this tube there is a filled with mercury, and the argon gas is present inside this lamp. So this results in the process of current between these two electrodes inside the tube. So the excited mercury vapor in the tube, which provides the UV rays which fall on the phosphor coating. Now what happens? Here we are having mercury plus argon gas, and this reaction takes place, and it produces the UV rays, and this tube is covered with the phosphor coating. So it reflects and it makes a path. It falls on this coating, and it is appear as a visible light. So now you can see this advantage and disadvantage. So we have the long lifespan, and the cost is very low. So it has a high luminous efficiency. It has the full brightness. So this has a high luminous efficiency. And here the disadvantage is here the voltage imbalance that causes on this choke. It produces a magnetic hum, and it causes the disturbance. So this is the disadvantage here. And here the sudden opening of the starter, here abrupt change in the current or flux linking in the coil. So here the applications are industrial, residential, commercial uses. This is found everywhere. And you can see the comparison now. So comparison between the incandescent and fluorescent lamp. So initially incandescent lamp, it produces the light by heating the tungsten filament, and in fluorescent light it produces the light by the electrical discharge. So it is called a gas discharge lamp. So discharge takes place through the mercury vapor, and it excites a phosphor coating. So here it is called a filament lamp. And in the incandescent light, the efficiency is around 10 to 17 lumens per watts. But here in fluorescent light, it has a high efficiency. So around 50 to 100 lumens per watt. So in incandescent, it is more amount of heat is released, so the efficiency is very less. And also the incandescent light consumes more electrical power for the same brightness. But in this lamp, in fluorescent lamp, it consumes less electrical power for the same brightness. So here we have the short lifespan, that approximately of 1000 working hours, and here it has the long lifetime, approximately 8000 to 15000 hours. So it generates a large amount of heat. We already discussed that it emits more heat. So here it is a less efficiency, and it produces, in fluorescent light it produces more heat, much less heat, so it is high efficiency. In incandescent light the glow is it gives a yellow light, and fluorescent light it is available as a cool white daylight. And here in incandescent light instant start without additional equipment. Here there is no additional equipment, but in fluorescent light it requires a ballast and starter. By using the starter, first initially we are starting. So here lower initial cost, but here higher initial cost and the lower operating cost. So it does not, in incandescent light it does not contain any hazardous material, but in fluorescent light it contains some of the mercury and it requires the proper disposal. And incandescent light is suitable for the decorative and residential lighting, and fluorescent light it is suitable for office, schools, industries, hospitals, commercial buildings, because it has a higher efficiency. Here it operates directly from the power supply without ballast, but here ballast or choke is requirement is needed because it used to regulate the current during the operation. So it has a low power factor. So it has a lower power factor unless a power factor correction capacitor is used. So light output decreases gradually as the filament evaporates and blackens the bulb. Here the light output decreases over time due to phosphate degradation and the mercury depletion. So next we can see the lighting, emergency lighting system on the ships. So here depending upon the ship's classification, that is we having ferry, ro-ro ship, gas carrier, etc. So for whatever the classification may be, according to the SOLAS convention, that should be the minimum requirement for the emergency lighting throughout the vessel. So this arrangement of the emergency lighting system must be such that any fire or other casualty in space containing the source, this associated transformer equipments are used, and emergency switchboard and the emergency light switchboard should not render any main electrical system. So here this is the electrical diagram for this emergency lighting systems. Actually here this is the main, this is run by the main generator, and here it is run by the emergency generator. Actually when there is a main failure, there should be immediate startup of engine, startup with the emergency generator within 45 seconds. So here this is connected towards two edges, or that here one is associated with this main generator and another connections are associated with the emergency generator. So actually here there is a source supply, this is the external supply. Here we are having two generator connected here, and also it is connected to shore. Either it can be connected to from the shore supply. If the ship is at docking period, then we can able to switch over the power to the shore side supply. So either we can operate by the main generator or the shore supply. So initially here we are having the 440 volt generating at 440 volt. According to the requirement, we can able to connect this lighting panel to the 220 volt, because this is essential for this lighting panel to operate. So here we are having 440 volt. This is converted to the 220 volt by we are having the step down transformer. So by this step down transformer we are step downing and we are connecting this to the lighting panel. So in case of the main supply failure, what happens, this is connected to the emergency generator. Here this emergency generator is operating by this battery mode, and here we are having the starting time, and within the 45 seconds it should act. So similar way we are connecting the same structure to this emergency generator line also. So here we are connecting this to the 220 volt supply line, that is emergency panel. Other than this, if you are needed the battery operating lighting systems, then we can able to converting to this to rectifier. So according to the need we can able to connecting this line. 24 volt DC supply also provided for some of the light applications. So actually the emergency light fittings, this is marked often with the red color indications to indicate their function. So it is continuously powered from the ship's emergency switchboard at 220 volt AC supply. So it may be supplied from the ship's 24 volt DC battery, means for example communication post in the wheelhouse and the machinery space, that is including in the steering flat. So it requires 24 volt DC supply, that is operated by the battery. So modern emergency lights are generally installed within the normal lighting fixtures. So some shipping companies now fit with a special battery supported light fitting that is provided in the main escape route, in the engine room, accommodation and the lifeboat station. So fluorescent tube can be designed to the house an emergency light that is supplied from the independent emergency source of supply. So as mentioned in this SOLAS regulations. So as prescribed in the regulations, we have to follow each and every lighting has the alternating one, so that even for any one of the lighting get defective, any one of the lamp is defective, then what happens? It should operate by the other alternative choice. So usually such emergency light in the accommodations are arranged so produce a light immediately upon the main failure. So the emergency lights at the boat station are switched on whenever required. Usually the battery will only function for a few hours. So such a duration of short period time. So the crew should respond to the emergency and he should be able to restore the power again. So the emergency lighting, how it is distributed? Initially the system is comprises of source supply or main generators that is feed from the 440 volt bus, and it is stepped down through the transformer, that is 220 or 110 volt. This is for the normal lighting panel, and a separate 440 volt, it is for the emergency generator also, it is fed in another side, and it is operated by the battery and the starting motor, which in turn supplies the emergency lighting panel, and it is distributed to the emergency deck lighting to the consumers. So now we can see the types of signal light used on the ships. So now imagine this is the ship structure, and we are going to see what are the types of lamp and what are the type of color and what are the angle it should cover and what are the distance it should be able to make visibility. So we are going to discuss now, and the types of signal lights that is used on the ship. So you are having masthead, stern light and the star, so aft and the ship at aground. So like that we are going to classify and what are the visible range for this light and what are the indications. So here it is available in red, green and white and blue lights. So here first thing is masthead light. So here if the vessel is less than 50 meter in length, then it is one light is sufficient. So these lights are carried out one behind the other on the two masts. So when the vessel is greater than 50 meter in length, so the forward light is slower and after is higher. So their visibility is at least 6 miles. It should be has a visibility of 6 miles, and they show a white light over the arc of 225 degree. So here it is having 225 degree mast light. So this is the 225 degree visible of light. It should cover the mileage of 6 miles distance, and it should cover the angle of 225 degree, and they show the white light over the area, and it has the 22.5 degree abaft of beam on both sides of the vessel. So next comes upon the side light. Side light, we are having the green light and the red light. Here the green light it indicates the starboard side and the red light it indicates the port side. So green light on the starboard side, it generally carried an arc of 112 degree, 112.5 degree range, and other side, port side, it is of red color light. It also covers the 112.5 degree angle. So it should has the visibilities of around 3 miles. Both the side lights, that is port light and the starboard light, it should cover the mileage of around 3 miles. Next comes one stern light. One stern light, it is fixed right astern and shows as a white light. It has the coverage angle of 135 degree and it is a white light. Here it should have the visibility of around 6 miles. That is here 67.5 from the right side of the vessel, from the right aft. So a towing light shall be yellow light. It should place above the white stern light. So here there is a having towing light which is of yellow color light and it should be placed above the white stern light. And ship at anchorage. So when the ship is at anchorage, so the ship of 50 meter or more in length will have one white light in the forepart of the vessel and a second white light at the lower level near the stern. So both lights are to be visible around 360 degree horizon for a distance of at least 3 miles. So if this ship is less than 50 meter, then only one all round white light is required. That's enough. So it may be of the reduced visibility but not less than 2 miles. Now ship under command. So if the ship is not moving and it is not making through this water, then the ship shall show only 2 red light, one over the other at least 1.5 to 2 meter apart. So that is visible all along the horizon. So for a distance of at least 3 miles. So these lights are either hoisted on a flag, hazard or the Christmas tree. So it indicates that ship is not under command. So if the ship is moving way through the water, then it shall show the 2 side lights and the stern light. Next is ship aground. So ship aground, every ship when aground shall show the appropriate anchor light for the vessels not under command. So this is, we are having masthead light. So it should cover the 6 miles and it should have the angle of around 225 degree and it is a white light. Side light, you are having green light and starboard light as starboard and port side we are having, and the starboard side we are having green light and the port side we are having the red light. So this is each one, it covered the range of arc of around 112.5 degree and it has one side from right ahead to 22.5 degree above of the beam and it should have the visibility of 3 miles. So one stern light, so already we know it should be of white light and it should have the arc of 135 degree and it should have the coverage 6 miles. Towing light, it should be yellow light, it is placed above the stern light. So ship at anchorage, so it should cover the 360 degree horizon all over and it should cover the mileage of 3 miles. So if it is not under command, then it should be provide 3 miles visibilities and it should show the 2 red lights which should for every alternatively it should show the indication either it should be hoisted on the Christmas tree, and when this ship is making through water, then the 2 side lights and the stern light should be indicated. So the ship aground means it shall show the appropriate anchor light and the 2 red light for the vessels that is not under command. Now we are going to see the navigation light. Here what is the purpose of navigation light? So for the ships there are some of the mandatory requirement for providing this navigation light. So the navigation light must be connected directly or through the transformer to the main or emergency switchboard. So there is no switches are to be in between the source. So in between the source and distribution board there is no need of switches. And here the mastheads, side and stern lights shall be connected separately to the distribution panel. So this is reserved for this purpose. So each light shall be controlled and protected in insulated pole by the switch and fuse or by circuit breaker that is mounted on the above distribution board. So in case of any main ship's failure or main failure, the switch should be changed over to the emergency supply. The bulb should have the uniform intensity output. So each light shall be provided by the automatic indicator which gives audible or visual warning in the event of extinguishing of light. So already we have for the solar's requirement we are having the emergency lighting, and if the lamp is reductive it should show the visible warning or any audible warning should be indicated, so that we can able to make change of the condition when it is of failure. So if an audio device alone is used, it shall be connected to the separate source of the supply. Example, for a battery. In a visual signal, it is connected in series with the light, means it provide the visual signal. During the failure it will provide the signals. So the visual device must be connected, that is does not extinguish the navigation light circuit. So what happens, it should not affect the navigation light. Provision shall be made on the bridge for the such a navigation light, so that should be transferred to the alternative circuit. So this is the navigation light schematic circuit. So what happens, initially we are providing the supply. Actually here we are connected with a relay coil. The relay coil is connected towards the buzzer or else towards the indicator. So the main function, this circuit is provided when the light is defected. When any defective lamps are identified, then it is given any indication. So the indicator light will be glow or the buzzer will be operated in such a condition. So during the normal operation, what happens here, we are having two choices, either from the main supply or from the emergency supply. So here from this panel we are providing the normal switch. So lamp over switch is there. Here we are having the two light. Here we are having, example, you are taking the foremast. So foremast we are having two light. So initially you are having the separate fuses and separate coil, and here also we can take into the other navigation light. So if you need this requirement, actually for we are having other navigation lighting also. So during normal condition it takes supply from the main supply and it supplies glows the light. The light lamp will be glow. In case of any failure, what happens, this relay will be de-energized. What happens when any of the light is defective, what happens, the relay coil, it should set the commands to the buzzer and the indicator system, so that the buzzer will make the noise, make the sound, and it will be provide the warning. Otherwise it will given by the indicator which give the warning that the lamp is of defective one. So what happens, normally the coil is energized during the normal condition. When the lamp is of defective, what happens, this coil is de-energized. So what happened here, normally this relay will be normally open, so that it is not connected to the buzzer. So in case of de-energization, when this coil is de-energized, what happens, here the strings pulls back to this buzzer and this connection is closed. So what happens, this make this buzzer to make a sound, so that we can able to provide the warning that the lamp is a defective one. So it should not affect the connection of other, because if it is provide the same thing, other should not get affected by the same connection. So this is the alternative navigation light circuit, that is energized. Another diagram you can see here. Here we are having the double pole supply changeover switch. So here it is connected normally this relay, same diagram. Here we are see that here this is an NC switch, that is normally closed, normally open, like that. So initially the relay will be operating at the normally open, so that this normal under normal working condition the circuit will be of this condition. Here this indication lamp, it is here we are having the backup resistor. So what happens, for the indication lamp to glow, we provide here the resistor, so that it provides this enough voltage will be supplied to this indicator lamp. Same diagram for same thing, here we are shown as a lamp is energized and de-energized situation. So when the double pole switch is closed, the navigation light is illuminated. So when at the time the current in the relay causes the relay to energize. So at the time the relay coil gets energized and it pulls the NC, normally closed contact to open. So what happens? Now our audio alarm circuit will be open. And actually there is a only low voltage lamp is needed for the indicating lamp. So this ensures this is done by this backup resistor, because this for glowing this indicator lamp we need less amount of low amount of voltage is enough for glowing this lamp. So what happens here, we are having the resistor. So what happens here, across this low voltage is provided enough for this indicating lamp. So it indicates that this lamp is under proper operation. So keeping the regulatory requirement in mind, if the indicating lamp fails, what happens? The circuit should be completed by the backup resistor, so the navigation light it does not fail. So in the event of a short circuit, the dedicated fuses will rupture. So that what happens now? It will isolate the defective lamp. So if the navigation light fails, what happens? A fuse will blow and the current in the circuit it stops, and then now relay gets de-energized. So if the relay gets de-energized, what happened? The normally contact switch it springs back to the activate the buzzer circuit. So what happens now? This time what happens? This is actually under normal operating condition. The relay is under open condition. So normally open. Now what happens? This relay gets de-energized, and what happens? It pulls back the spring and it closes this circuit. Closes the buzzer circuit. So now the normally contact brings back this to the activate the buzzer circuit. So in case of the failure of the main chip, what happens? The double pole switch may be switched to the emergency supply. Actually here we are having this main supply or emergency supply. So this is we are providing the double pole switch. If in case of main supply, we are providing this connected to the main supply. When this main supply is failed, then this changeover switch will be connected to the emergency supply, and this light will be operating by the emergency supply. So here we are having the alternating one, emergency and the main supply. So caged filament is provided for this lamp. Why? Means because it should withstand the shock or any mechanical vibrations or take place, then it should be protect the lamp. So the caged filaments are kept so that inside this lamp is placed in the caged filament. Next we can see the proper selection cable for the shipboard lighting. The selection of the cable for the shipboard lighting, it is an important aspect for the marine electrical system. So the cables must operate safely and should be reliable under harsh environmental condition. That is, we are going the shipments, we are going to face many environmental issues. That is, such as moisture, then salt content, then vibration, so that high temperature or any other mechanical stress. So these following factors to be considered for selecting this cable. So first selection is based on the voltage rating. So the cable voltage rating that should be equal or should higher than the system voltage. So if you are having the specific range, that is if you are needed 230 volt AC or 440 volt AC, so the cable should be selected accordingly. So it should have the ratings, it should withstand the proper range. So the voltage range should be properly kept in mind while choosing this cable. So second one is the current carrying capacity. So the cable should be capable of carrying the maximum load current. So when it has the proper, when it is excessive heating is there, it should not melt. So the proper, it should be selected accordingly. So the conductor size is chosen. So it is based on the lighting load and the permissible range current rating. Next is the third factor is conductor material tinned copper conductors. So this is preferred because they offer high conductivity, because it is a good conductor and excellent resistance to the corrosion, because we are to keep in mind that is for the ship structure we have to face the corrosion problem. Okay, so that it should be capable of providing high conductivity and excellent resistance to the corrosion that is caused by the marine environment. Next is insulation material. So the insulation material, it should be capable to withstand the heat, moisture, oil and the chemicals. So the common insulating materials are cross-linked polyethylene, and ethylene, propylene rubber, polyvinyl chloride. So these are the common types of insulation material required. Next factor is the fire resistance. So the shipboard cables, it should be flame retardant. Okay, it should not expose to any fire or any fire hazard situation should not happen. So the shipboard cables should be flame retardant. So low smoke and halogen free. So in order to reduce the smoke and any toxic gas emissions, it happened for during the fire conditions. So it should not happen. So it should be selected for this way. So next is the mechanical strength. So the cable should withstand this. Already we told that, we discussed that it should withstand the vibration and shock. So this cable should withstand the vibration, abrasion, bending, any mechanical impact incurred on the ships. So that the mechanical strength is selected. Next is water and corrosion resistance. The outer shell of the cable, it should resist the seawater, humidity, oil, fuel and any UV radiations. Next is voltage drop. The cable size should be selected to ensure the voltage drop and it remains within the acceptable limit. So typically not more than 3 to 5%. Next is the environmental condition. The cable should operate reliably over a wide temperature range and under the continuous vibrations. So the environmental condition should be kept remember while selecting this cable. So next is compliance with the marine standards. That is, cable should comply with the marine regulations such as it should specify the standards. That is, electrical installation in ship, it should have the IEC 60092 and it should has the requirement of IEEE standards, and it should classify the society requirements, that is ABS, DNV, Lord's Register and Bureau Veritas, etc. So these are the things, it should meet the specific requirement for this thing. For this standards, it should meet this following requirement of these standards. Okay, thank you.